Okay, now in this lecture, I'm going to introduce you to a bit of vector arithmetic, and I've already created the Numpy arrays x and y using np.array, and that is because I imported Numpy as np. And you can do the same, and we will start by creating very simple vectors. And if you remember, these are the rank 1 vectors that we had created previously in the previous lectures, and essentially we perform the bespoke vector arithmetic on these. So the simplest vector arithmetic operation that we can perform is an addition operation. And I have specified x plus y, and this is how it works out. So this is my first vector x, my vector y, and now the addition is done element by element like so. So the value at this location a1 will be added to the value at this location b1, and so on. The same goes for subtraction. And as you can see, this is the result I get. 3, 5, 7. 1 plus 2 is 3. 2 plus 3, 5. 3 plus 4, 7. And we can also perform scalar addition, and which is the act of adding a constant to a vector. And you can already see that I have my vector 1, 2, 3, and I want to add a scalar, which is 2 in this case. So what happens here is that 2 is going to be added individually to all the vector elements, which are numbers in this case. And that is how I get 3, 4, 5. 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, and the same thing happens when I subtract. X minus y, so 1 minus 2, 2 minus 3, and so on. And let's just do it the other way around. Remember, it's going to be element by element. There. And now for multiplication, there are two ways of carrying out multiplication. The Hadamard product, and we discussed it in the previous lecture, that Hadamard product is basically, that is how we get a vector at the end of our multiplication, and with dot product we get a number or a scalar, basically a scalar or a constant. And if we want to implement these in Numpy, the syntax is slightly different for them, and I'm going to just show you how. This is the product, and as you can see, it does element by element multiplication. So 1 into 2 is 2, 2 into 3 is 6, and 3 into 4 is 12. The same output here. And now dot product. there. So following the schema for computing dot products, we ultimately get a scalar 20 at the end. And now for division, again, it's element by element. So when 2 was divided by 1, we end up getting 1 and so on, and all the numbers are reported as integers, so we don't see the decimals. But essentially, these are some of the most common arithmetic operations that we can perform on one-dimensional vectors. And now we are going to look at some of the arithmetic operations we can perform on matrices.